Welcome back. Now we are going to take the third lecture. We are going to talk about logarithm and e power x and a power x, the derivative of, and the power tower, which is just a variable, power variable. We're going to talk about how to differentiate them. I'm going to explain and then give two examples on every one and at every single one of them. And at the end, I will solve maybe 14 examples on them. Okay. Before starting, we need to know some properties of logarithm. If you already know them, you can skip this part. Log 10 of x, the base 10, we can just write it as log x. We don't have to write 10. Any other thing, we just write it, we write it like if it's log a x, we write log a x. Log of the base a x. Okay, but this is 10, we don't have to write it. Log e, we just say it's ln x. Log a x plus log y with the base a also. When the same base, we can have them in one log and multiply them by each other, which is log xy here. If it's minus sign, we say that's log x over y. Okay. If we have the same base here inside the log, it's just equal to 1. So if I say log 10, it's equal to 1 because I didn't write 10. If I didn't write it, it means it's 10. So it's log 1. Ln e, it's equal to 1 because ln e is just log to the base of e. This is a very important rule here. Log a x power n, it's equal to n multiplied by log a x c. You just get the power here. Okay, now to look at the logarithm rule. Okay, we have dy dx, a function here, a log to the base a that has a function in. Its derivative is just the function multiplied by ln a, the base, right? And in the denominator, we just differentiate the function. It's an easy rule, but it can be tricky while solving a lot of differentiation. So let's see this example. We can see here that this is log x power 2 plus 5. It's power 5, right? From the n rule, the last rule I said, we know that we can write it as 5 log x power 2 plus 5. That's it. Now to differentiate this, you can say 5 multiply it by the derivative of the log, which is here we put the function inside the log multiplied by ln the base. Here I didn't write the base, so that means the base is 10. So ln 10. X power 2 plus 5 to x and 5 is just 0. Don't have to write it. Okay, now to look at this example, we can say, okay, we write here y dash is equal to, okay. Here we have ln x power 5 minus ln x power 3. We can say that it's ln x power 5 over x power 3, right? Which is equal to ln x power 2. Now to differentiate x power ln x power 2, of course we can put the ln is the power is a 2 next to the ln here. So to differentiate it, we're going to say, okay, so now the 2 is over here, okay? We got the 2 over here from the last rule. 2 and ln x is going to be x ln e that you don't have to write because ln e is just 1. Because ln e is just log to the base e. If you have the same base and the same inside the log, it's 1, right? So you don't have to write ln e. and the derivative of x is just 1. Okay, now we have another example here for ln. Ln x plus 1 over root x minus 1 minus 2, which is equal to ln x plus 1 minus ln root x minus 2, right? From the properties we took in the first of the video. It's a division, you can have it minus. Okay, root x minus 2, the root here is just x minus 2 power half, right? So you can write power half here next to the ln and remove the root. And that's how we're going to solve it. I have y dash is equal to the derivative of this is x plus 1 ln the base, which is e, and you don't have to write it, it's 1, and the derivative of x plus 1 is just 1, minus ln the derivative of ln root x minus 2, so this is power half, right? So now we can write half, and the derivative of ln of x minus 2, and x minus 2 here is just 1. In this example, it's just a normal root derivative, okay? It says that y dash is equal to 2 root 1 plus ln t. What is the derivative inside the root? Here is 0, because 1, plus the derivative of ln t, which is 1 over t. Okay, now for the second part in this video, we have the derivative of e power x and a power x. A power x is any number power x, and e is just a special case because e is just a number. It's 2.7 something. Okay, so what is the derivative of a power of function, number power of function, number power of variable? We write it as it is, multiplied by the derivative of the power, multiplied by ln the base, which is a here, so multiplied by ln a. Let's see an example on it. We have y dash is equal to a, we write it as it is, x power 2 plus 1, multiplied by the derivative of the power, which is 2x plus 1, multiplied by ln the base. Oh, okay, this is not 1, of course, it's 0. Okay, the second one, we have y dash equal e power root x plus 1. Why is e a special case? You will see. Derivative is just the normal derivative of the power times 2. And what's the derivative inside the root? Is just 1. Ln e. You don't have to write ln e. That's the special case in it. You don't have to write ln e because it's just 1. Okay, let's talk about the power tower. What is a power tower? It's just when a variable power variable. How to solve that, right? Um, it doesn't have a rule. It's just a way of solving it. Okay, it's by using the logarithm function. How to do it? You ln both sides. Of course, you can't ln just one side, right? If you are going to multiply this side by 2, you have to also multiply this side by 2. So we are going to ln both sides. Ln x power x. What's ln x power x? We can also write it as x ln x. Now we can differentiate it. It's a product rule now. So let's solve it. Ln y. What is ln y? We have y, okay? What is the derivative of y? It's just y dash. We always do that in every example. We always say y dash equal, right? Because we are differentiating with respect to x. Okay, equal x ln x, the first as it is, multiplied by the derivative of the second, plus the second multiplied by the derivative of the first, which is just x. Okay, are we going to leave it like this? No, we have to get y dash at a side alone. So we say y dash is equal to x. X over x is just 1 plus ln x multiplied by y. Okay, now this y, you can remove it and put x power x. Another example on a variable power to a variable. You have y equals x power 2 plus 1. We are going to ln both sides equals to this is powered. You can put it down when it's you're going to ln, right? So that plus 1 ln x. Now you can differentiate both sides by saying y y dash. Of course, this ln e we don't write it equals to a product rule. The first multiplied by the derivative of the second, which is 1 over x, plus the second, which is ln x, multiplied by the derivative of the first, which is 2x, and 1 is just 0. So y dash is equal to this function multiplied by y, and don't forget the brackets. Okay, now we have 14 questions to solve and a question at the end also to solve. It was from the previous lecture. I just found a better way to solve it. I will say that's the end. Okay, the first question we have ln x over 1 plus ln x. So this is a division rule, right? We're going to say 1. We're going to say y dash is equal to 1 plus ln x all power 2 with the denominator and the numerator multiplied by the derivative of the numerator minus the denominator multiplied by the derivative of the denominator, which is also 1 over x because 1 is 0. You can remove this, and just 1 will remain. The next question here is y equals root x power x. You can write it as y equal to x power half x, right? So now it's ln y equals to half x ln x. And now I think it's very easy. So the solution is y, the derivative of y is y dash, equals to half, open bracket, this is a product rule, x ln x, so x multiplied by 1 over x, which is just 1, plus the second, which is ln x, multiplied by the derivative of the first, which is x, which is 1. You don't have to write it. Multiply both sides by y, remove y, and put its value. Okay, now for question number 3, we have ln x. What is the derivative of ln x? Y dash. Okay, we are going to differentiate ln that contains ln x, right? So the function inside ln is ln x. So you write it down here. Ln x multiplied by ln e, which is 1. You don't write it. Now differentiate the function itself, right? What is the derivative of ln x? is 1 over x, right? That's equal to 1 over x ln x. Now, to see, let's write solution. To see 3 ln x, 3 ln x, we are going to look at this, right? It's a function, ln x. Also, the base is e, you don't have to write it. Now we want to differentiate this, right? This ln contains ln x. So what's the derivative of ln that contains ln x? So we are going to say ln x. Here is e. Don't have to ln e. You don't have to write it. Now differentiate the function inside of ln x, ln itself, which is ln x. Differentiate ln x, which is 1 over x. So this is equal to 1 over x ln x ln x. Okay, for this question, this is a very good question because it combines a lot of rules. Always, before solving, try to simplify even the smallest thing while solving, okay? Here, we are going to say this is equal to. We can see that ln e power x, right? So we can write x next to it. So it's ln e. Ln e is just 1. So what remains here? It's just x. So this is equal to root x power 5 plus 6 power 10 over x plus 10 power x. And now to differentiate it, we say y dash is equal to, this is a root, right? So we write 2 root x power 5 plus 6 power 10 over x plus 10 power x. Let's differentiate this. Differentiate what's inside the root, right? What's inside the root is a division. X plus 10 power x power 2, x plus 10 power x whole power 2. Now you put the denominator in the numerator, which is x plus 10 power x multiplied by the derivative of the numerator. Okay, what is it? X power 5 is 5, x power 4 plus 6 power 10. 6 power 10 is just a number. You don't have to write it, it's 0. Minus the denominator, which is x power 5 plus 6 power 10 multiplied by the derivative of what? Of the denominator, which is x is just 1 and 10 power x is the one of the rules we took today. 10 power x going to be 10 power x. The derivative of x is just 1. Don't forget ln 10. Okay, now for question number 6. We have log to the base 2 contains x, log to the base 5 x. Okay. As you see, the x is multiplied to log to the base 5x. So we can separate them, right? And write it as log 2 x plus log 2 log 5 x. It's just easier. Now to differentiate, we have log to the base 2x, which is going to be, we're going to say y dash equals, sorry, y dash equal log to the base 2x. How to differentiate that? It's x multiplied by ln 2. Now it's not ln, so we write it. The derivative of x is just 1. Now plus log to the base 2. Okay, what's inside it? All of this. So we write all of this here. Log 5 x ln 2. Now to differentiate log 5x, we're going to say x ln 5, and the differentiation of x is just 1. For this example, we're also going to separate it, but for ln, I'm going to say ln x plus ln e power negative 2x, which this we can write it as, negative 2x ln e, which is equal to negative 2x, right? So this is equal to ln x minus 2x. Now we can differentiate this. Of course, in the first we can differentiate it, but it's easier like this. Y dash is equal to 1 over x minus 2. Okay, now for example number 8, we see that y is equal to pi power ln x. Pi is just a number. I just made it to make sure. So now pi power ln x, as it is, the derivative of the power. So the derivative of ln x is 1 over x ln the base, which is pi. Now for this example, 6 power e power x power 3 plus ln x. So we see y dash is equal to 6 power e power x power 3 plus ln x as it is. Now the differentiation of the power, which here is all of this. So now the differentiation, which is for the e, is e power x power 3 plus ln x. You put it as it is, multiply it by the derivative of its power, which is 3x power 2 plus 1 over x ln e. You don't write it, and don't forget ln 6. And that's it. Okay, now for example number 10. We look here. We say that y is equal to x power x power x. Of course, we are going to ln both sides, so ln y equal to x power x ln x, right? Because x is power x power x. Okay, but we still have x power x. So we are going to ln both sides again. Ln both sides again, which is going to be ln y is equal to ln all of this side, not just this. So ln x power x ln x which is ln y equals to x ln x, because now we can separate them, right? They are a product. We can separate them to addition. Plus ln x. Now to solve this, we're going to say what's inside the ln? It's ln y outside the greatest ln. Okay? Ln y. What's the derivative of ln y? 1 over y. Not 1, sorry. We are differentiating with respect to what? To x. So this is y dash. Okay, what is the derivative of y dash? Is y double dash. We will go to that in later videos. This is equal to x ln x. It's a product rule, right? So we're going to say x as it is multiplied by the derivative of the second plus the second multiplied by the derivative of the first, which is 1, plus ln x. What's inside the greatest ln? Ln x ln e. What's inside the greatest ln is x. So differentiated is not sorry. We differentiate the whole ln. Ln x is 1 over x. Now you can say that y dash, if you multiply both sides by y and ln y, because you know this y will just come here, right? So multiply both sides by y and ln y. So y dash will be alone equals to, and you can remove every y also and put x power x power x and make it in one step. X, this is just 1 plus ln x plus 1 x over x ln x multiplied by y, which is x power x power x. Now what's ln y? Of course you can say ln x power x power x, or you can look here and just put x power x ln x. So you also multiply this by x power x ln x. Very bad x. Okay, now if we have y is equal to x power x power x power x till infinity, how can we solve that? Okay, we know that y, what's y? It's equal to x power x power x power x till infinity. Okay, what's y to the power 2? Like, what's x to the power 2? X is to the power of what? X is to the power of x power x power x till infinity. So x is to the power of infinite x's. And what's y? Y is equal to infinite number of power of x's. So we can just remove this and put y, right? So we can say that y is equal to x power y. And now to differentiate it, we can say that ln, let's write it here, we can say that ln y is equal to y ln x. Now to differentiate that, we can say that y, what's the differential of y? Y dash. We don't have to write ln e, and that's equal to y ln x, which it's a product rule. So the first multiplied by the derivative of the second plus the second, which is ln x, multiplied by the derivative of the first. What is the derivative of y? It's just y dash. Now we want to have y dash alone in the side, right? So we're going to say y dash over y minus ln, or let's write it, y dash ln x equal to y over x. We can now take y dash as a common factor. So we can say y dash is equal to, if we take y dash common factor, we have 1 over y minus ln x. Let's make it in 2 steps. So now 1 over y minus ln x equal to y over x. And now you can divide by this, which y dash is going to be equal to y over x multiplied by 1 over y minus ln x. And you can remove every y and put x power x power x and 3 dots. 3 dots indicates it's still infinity. You don't have to put more or less, just put 3 dots. More doesn't make sense. Okay, now we have like 3 or 4 examples. 3 examples that can be solved by logarithm. Okay, and this first question, of course, this can be solved as a product rule, right? Two functions, but we are going to solve it using logarithm. So we are going to ln both sides. So ln y is going to be equal to, okay, 2. I'll make it in one step and explain it. Plus, let's see. Okay, so what happened here? We ln both sides. The ln has inside it a product rule, which you can separate, right? Okay, and this was power 2, and you know you can just put the 2 here. This was power 4, you can just put 4 here. Now to differentiate, wait. Okay, 1 second. Okay, now to differentiate, we can say that y dash, oh my god. Okay, now to differentiate, we can say that y dash over y is equal to differentiate this, we're going to say 2 multiplied by the derivative of ln, so x power 2 plus 2, and of course then you don't have to write. What's the derivative of x power 2 plus 2, which is 2x plus 4 multiplied by the derivative of this, which is x power 4 plus 4. What is the derivative of this? It's 4x power 3 plus 4. No, plus 0. This is 0. The derivative of 4 is 0. And you can multiply both sides by y and say y dash is equal to all of this in a bracket multiplied by y. And you can remove y and put all of this. Okay, now for this question, I'm going to solve it in 2 ways. The logarithmic ways, and another way is a product rule, because these are 3 functions multiplied by each other. The first way, we are going to ln both sides. Of course, these are multiplied to each other, so we can say plus plus plus. So this is just ny equals to root x. Ln root x is just half ln x, because root is power half. Okay, this is just plus x power 2 minus, oh my god, x power 2 minus 1. Why? Because the power, you can drop the power, right? Over here. And ln e is just 1, you don't have to write it. Plus 2 over 3 x minus 1 ln x, okay, x minus 1. Let's differentiate both sides. So ln y, why does it look like that? Y, here y dash is equal to half multiplied by 1 over x plus 2x. All of this, we're differentiating this. Oh, this is x not 1 minus x. So here we say minus 1 plus the derivative of this, which is 2 over 3 multiplied by the derivative of ln, which is x minus 1. The derivative of x minus 1 is just 1. Now you can put y the other side and put it as this value. Okay, the other way for solving this is the product rule. We have y dash equal to, we have here three functions, so we are going to take this, the root x as a function, and all of this as a function. So we are going to write first, right, root x multiplied by the derivative of second. What is the derivative of the second? The second function is also a product, so we are going to use a product rule here. We're going to say the first x power 2 minus x multiplied by the derivative of the second, which is 2 over 3 x minus 1 power 2 over 3 minus 1 going to power negative 1 over 3 plus, let's see, the second equation, x minus 1 power 2 over 3 multiplied by the first, by the derivative of the first equation, which is going to be e power x power 2 minus x multiplied by the derivative of its power, which is 2x minus 1. Okay. Plus the second multiplied by the derivative of the first, which is just 1 over 2 root x. Nice. Now for this question, as you can see, this is just a normal root over a root that contains a division, but we're going to solve it the logarithmic way. So we're going to say y equals. I'm going to say ln y is equal to ln root x minus 1 root x power 4 plus 1. Right? You can do that to the root. If you don't know, if you have, for example, x over y all power 2, right? You can say that it's x power 2 x power 2 over y power 2. It's the same thing. So what's root? It's power half, right? And this is division inside the ln. So we can say that ln y is equal to half ln x minus 1, and it's a division, so you can say minus half ln x power 4 plus 1. Now to differentiate both sides, we say y dash over y is equal to half multiplied by x minus 1, 1 minus half. The derivative of this is just x power 4 plus 1. What's the derivative of x power 4 is 4 x power 3 plus 1. 1 is just 0, so you don't have to write it. Now for this question, at the end of the last lecture, which is part 2, Um, this is a better way of solving it. Um, I will explain it fast. You can you can just write it as a bracket, right? X plus 1 power 2. So now the third root for the bracket power 2, you can write it as 2 over 3. And because it's in the denominator, when you put it in the denominator, it's going to be negative 2 over 3. We have the same base. We're going to add their powers, which is like this, and just differentiate it to 4 over 3 x plus 1 power 1 over 3.